All right, Mr. Ford, back here. Just filmed my lesson for section 6-7 using trigonometric ratios in word problems, real life context here. So we're not going to get to real life context in these examples I'm going to do for you right now, but we are going to use kind of some vocabulary here. If you're looking at this one, they're talking about observers, they're talking about angle of depression, they're talking about, well, they don't talk about angle of elevation. They do talk about angle of elevation there. So year in and year out, people, especially questions 2, 3, 4, and 5, they find kind of confusing because it's kind of vague what they're asking you to do. But they're asking you really to flex this new vocabulary that just came up in the lesson. So I'm hoping you watch that about 18-minute lesson that we had today, talking about angle of depression, right, down from the horizontal, versus angle of elevation, up from the horizontal, right? Horizontal to the ground, parallel line, horizontal ground, up or down, right? That kind of thing. Up is angle of elevation, down is angle of depression. 90 degrees up, elevation, 90 degrees down, angle of depression. Anyways, for an observer at B, okay, so B's pretty low. Hey, here's a horizontal. We can assume horizontal being horizontal to the bottom of your book, right? So AC is the horizontal. They tell us to that, right? Horizontal to the back, to the bottom of the book. So giving that to you as a reference point here, or a reference line. For an observer at B, what's the angle of elevation of D here? So B, we got somebody hanging out with some spiky hair. There we go. And their eyeballs are where their mouths are. But anyways, what's the angle of elevation of D? Okay, they're at point B. They're looking at D, 15 degrees, angle of elevation. All right, looking up. They got to look up, not super much, but 15-degree angle. Not 90 degrees, not 75 degrees. That'd be way too high. They'd be way over D. They're just looking up kind of slightly, 15 degrees there. All right, from D, what's the angle of depression of B? Okay, so from D, angle of depression from B. Ooh, that's tricky. Here you had to watch the lesson video to realize that if you're up at D, it's kind of like the lighthouse problem, right? Kind of like, so it's not 75. 75 is the sucker answer right there. It's angle of depression from the horizontal. Okay? So if I'm at D, I'm looking down from a horizontal vantage point. Here is AC, so I'm looking down from a line that's parallel to AC. I'm looking down from another horizontal line. So I'm looking down from this. Okay, so here I'm going to introduce another horizontal line. If it's horizontal to AC, if it's horizontal, it's going to be parallel to AC, because in a plane, if two lines are both horizontal, they're parallel. I think that's actually something that we don't talk about until chapter 11, coordinate geometry, which we won't even get to this year. But anyways, I'm supposed to get you thinking about that there, okay? So here, this is horizontal, right? Here, this would be 0 degrees right here. But here, we're going downward here. This is 75 right here, so what's it got to be? Well, if I'm at D and I look 90 degrees down, I'm looking at point C right here. That would be a 9-degree angle of depression. Go back 75 degrees. Hey, I'm looking 15 degrees down. Okay, 15 degrees down. So these are going to be the same, right? These are going to be the same because if you're at point B, your horizontal is parallel to, if you just climb up a hill and you look off to the horizontal, that's parallel to your original horizontal here. So anyways, these are actually alternate interior angles, right? And if you're standing perpendicular to the ground, right, you are parallel to one another. And so angle of depression from a higher vantage point will be the same as the angle of elevation looking up to that higher vantage point here. Okay, so they're both 15 degrees. Hopefully you guys get that one right when I do the Jamboard on Monday. An observer at A measures an angle of elevation of D. Is the measure greater than 15 or less than 15? So an observer at A, oh, that's a good call. I like this question. Yes. This is good. It's going to be less than 15. Okay, less than 15. And how do you figure that? Well, here, this would be, well, here I have a larger angle. So if I'm at A and I draw it in, this is getting messy, friends. So if I'm at A, some kids don't like getting called friends. Students, people my range who actually are like I'm friendly with. They're like, hey, this is not gonna do the friends thing. Oh, whatever. So if I'm at A here, look at this. This is definitely right because this is 75 degrees here. This is sort of that property, that parts property of inequalities. That if you know that, well, angle ADC, the measure of angle ADC is the sum of measure of angle ADB plus DBC. So that means, BDC. If BDC is 75 degrees plus whatever this is equals measure of angle ADC. Angle ADC is going to be larger. It's going to be greater than 75 degrees here. Okay, this will be my logic for it, for proving this. They don't ask you to give the logic right here, but this is greater, right? Here, this is greater than 75 degrees. So if that's greater than 75 degrees, we're going to have less than 15 degrees left, right? Because 75 plus 15 would be 90. So if this is 76, this is going to be 14 degrees. If this is 77, right, it's greater than 75 degrees, this is 13 degrees. The thing that we have in common is that this is going to be less than 15 degrees here, okay? So, right, the further away you move from a fixed item that's up high, from a fixed elevation point, so maybe we do an example here, right? Let's pretend this is the building here, right? Pretend this is the building here, but this is, right, angle of depression going down where you're standing. Let's say I'm standing here. This is a pretty big angle of elevation, right? Pretty big angle of elevation to look at the top of the skyscraper, But as you move further away from the skyscraper, you don't have to look up as extreme an angle. You don't have to hurt your head. Hey, I'm going to move backward, so I have to look up a little bit here, okay? It's why you're at a movie theater, right? If you're at a movie theater, you don't want to sit in the first row because then you're like this. And then you spend 3 hours watching Avengers Endgame, and you're just like, why didn't they just end the game? So bad. Because my neck is really, really hurting me. That's why you want to be like second level, right? Second level here, and watch the movie and enjoy. And Thanos does die at the end, right? Does that happen? No, I don't know. All right. Anyways, hopefully that helps. I know I do get questions about those. It's a little tricky. You got to think them through, but you're also getting used to things here. I'm hoping you're watching this with me. The lines shown are horizontal and vertical lines, except for HT and HG. Okay, let's see here. Yeah, there we go. We got some transversals here in between horizontal lines. We know that these lines are parallel if they're horizontal. Sometimes we'll mark them up parallel. That might come in useful later in this problem. HT. Okay, so they don't even name this line here, but whatever, it's not going to matter in this problem. But HT and HG are not horizontal, so they're going to intersect at some point. Anyways, give the number, the angle, and its special name. Okay, so here, every year is like, what does that mean? Special name? I'm not sure. Well, guys, what was the vocabulary in today's lesson? Okay, so your either special name is either going to be angle of elevation or angle of depression. Okay, an angle here in this context of these trigonometry problems is either going to be an angle of elevation or it's going to be an angle of depression, okay? A person at H cites T, okay? So that means if my person's here, yay, they cite T, okay? They're looking up here. The Captain Hook. Okay, where are they looking? From the horizontal, they're looking up. Okay, they're looking up. So angle 2 is what we're talking about here. Yeah, right? This is that person at H. This is their horizontal. Hey, HZ is horizontal. Every line shown is a horizontal and vertical line. So that means all three of these are horizontal. They're all parallel to one another. But anyways, this is a horizontal, HZ. Horizontal. You get it? Horizontal, HZ. They chose HZ intentionally there with purpose. I like being intentional. I like having purpose. That's good. So to spot T up here, they got to do angle 2. Okay, angle 2. And if they're here and they're forming angle 2, what are they doing? Are they looking up? Are they looking down? Are they doing angle of depression? Or are they doing an angle of, they're doing an angle of elevation, right? Look up as elevation. Or are they doing an angle of depression? They're looking down. That's right. Angle 2, and I'll just write elevation. Elevation. You guys don't know that song. It's by U2. You ever heard of the band U2? I don't know. Person at H cites G. Okay, all right. This person hanging out there, they're looking down from the horizontal. Okay, so they're obviously going to be angle 3, and that's going to be depression. Angle of depression. Manic depression's a frustrating mess. That is Jimi Hendrix. I'm so old. I've become so much older since becoming a teacher. I'm singing songs in the 60s now. What the heck is that? All right. Anyways, you guys even heard of Jimi Hendrix too? I don't even know about, like, Jimi Hendrix. I feel is like not nearly as relevant now than when he was in the 90s even. Or the 2000s when Mr. Fort was coming of age. All right, we got here. A person at T cites H, where they're looking down. That's got to be an angle of depression. But what angle? Well, hey, the thing you need to ask yourself is here, what's T's horizontal? So if I'm at T, I'm looking horizontal to the ground. I'm looking along here. So this is with respect from the horizontal, okay? From the horizontal. From T, we got to look down. So that's an angle of depression. So that means we got to be talking about angle 5, angle of depression here. So we're flexing our knowledge and our working skills with this new vocabulary and our feel for this. It's okay if you're not getting this right away. That's why I'm practicing with you right now. Okay, a person at G cites H. Okay, that's got to be an angle of elevation, and that's got to be angle 8. Okay, so G, okay, it's Horizontal is, well, I'll put here GY, okay? GY is horizontal. It's horizontal from G. So you got to think about with respect to the horizontal, right? GY, well, that that means that YGH is going to be the angle there, right? Because from the horizontal, look up. We got our ray going up right here. So that's going to be an angle of elevation. It's going to be angle 8. And we got elevation. I'm going to play that really lame song tomorrow before class. Oh, man. Winning. Winning here. All right. Stay 2 equations. You know, you lose your mind when you're stuck in a room like this for a whole year. I haven't been there for a whole year. Actually, I've moved, but for half a year at least. I've been stuck in this room. You haven't seen me anywhere else. State 2 equations you would use to find the value of x. Sure, why the heck not? We've done that already. We've totally done that a whole bunch recently. So first of all, let's make this theta. Okay, let's make this theta. Let's make this alpha. Okay, so let's see here. If this is well, let's maybe do different colors so we see this here a little more clearly. Let's make this one alpha. Make that one theta. So we'll start with black already, right? This 20-degree angle. X is going to be the opposite side. Okay, this is the right angle right here. Okay, so we label it hypotenuse. I'd always just sketch it out. Label it real quick. Get your opposite. So we got opposite over hypotenuse. So there we go. Sine of theta. Okay, so sine of 20 degrees would equal x over 84. Why is Mr. Fortin yelling? Well, he likes this. And you know, you do this for a few years, you get kind of bored of it. To be honest here. All right, anyways, 70-degree angles right here. There's a reference angle. Yeah, a lot less. 70 degrees here. And, you know, x is no longer the opposite side for this here. Okay, so this is the right angle. This is still a hypotenuse. That's easy. You don't even need to label that. There's only one hypotenuse in a triangle. So here, this is the opposite side. So if it's not opposite, it's not hypotenuse. What is it? It's the adjacent side. Okay, adjacent means in life, right? Oh, we're adjacent to this thing means we're kind of like right next to it. So if the 70 degrees is here, this is the adjacent side. Adjacent, like it's actually part of the 70-degree angle, right? Because 70-degree angle, this reference angle here includes the hypotenuse and that leg. And that leg here got to be the adjacent leg if it's part of the actual reference angle itself. Okay, so what we have here is we can use not so. I said so. I shouldn't have. I said SO, not SOH. We're not using so. We're using what? We're using something using adjacent and hypotenuse. So what is that? Ka. So katoa. Noah, love it. Use it. Flex it in future classes. Don't make Mr. Fortin look bad. Don't look bad at college parties when you're talking about this constantly. It happens constantly. So ka. And what does the C stand for again? All right, cosine, cos, okay, right? It's all about it's just getting faster with stuff, practicing. Cosine of 70 degrees equals what? Well, the adjacent over hypotenuse, and that's x over 84. And which one will be easier to solve? Well, they're both pretty easy to solve. We got x in the numerator, just have to multiply both sides by 84, plug it into a calculator, you get x. Do you have to do that? No, it just says state 2 equations you could use to find the value of x here. And there it is. There are your classroom exercises. Hey, Mr. Fortin went pretty far with it. There's not too much more to do. Let's check out to see if we have the assignment here left here. Hey, you only got to do these ones. That's not too bad. Number 1, 3, 6, 8 through 11, 13, and 14. Not too bad for a weekend here. Have a great weekend, and yeah, we'll do review chapter 6 Monday. Maybe we'll do another fun little trig task on Wednesday, something like that, and then we'll have our chapter 6 quiz on Friday. Take care, guys. Bye. Message me if you have any questions.